Okay, good afternoon. I'm going to get started. Welcome to Ignite. My name is Mark Fussell. I'm a program manager that works on the Azure team. I work on the Azure Service Fabric team. I'm super excited to be here to talk to you about Service Fabric and about microservices. And this talk is a prelude to 3 other talks that we've sort of got lined up, one a bit later today and 2 more in the next following days around Service Fabric. And the scope of this talk is to really give you a bit of an understanding around how we think about what this newfangled thing is, microservices, how that relates inside the industry, and how does Service Fabric fit in with this and what you can do with it. So the takeaways of this is an idea of really what is it that you can build from a developer perspective, but also how you think about managing systems around that you build. And effectively, we built a whole bunch of services in Microsoft over the years, over tens of years we've been building things. And the roots of Service Fabric go back to services that we built, particularly Azure databases. And Azure databases was a project we started well over 10 years ago to take relational databases and host them in the cloud. You know, SQL Server effectively hosted as a relational database. And as we did that, there were many lessons that we started to learn. Things like you don't own the hardware. You can't go and touch the physical machine and say, you know, that's my machine there. It's somewhere out there in the ether inside a data center. Things go bad and things go wrong. Processes fail, machines die, disks go bad. You have to be able to deal with all of that. You have to deal with the fact that scale can be unpredictable. You may be lucky up front to know I'm building a system for 1,000 users, but often as a service, you don't know what the intended scales are. And then we also found that effectively managing systems and how we think about how we do the rollouts and the deployments and the upgrades was actually a harder problem sometimes than building these systems. If we didn't think up front about how do we do no downtime upgrades, the ability to roll an application out and roll it back consistently without having an intermediate state between them all, telemetry from all of this, and understanding of the running system, particularly in the distributed systems arena, things went bad very quickly. Cost became an issue, how we ran things on machines and how we effectively maintained costs. We cared a lot about security up front. And in the end, when we built all these services, we wanted our developers to be productive building apps, not every single team building their own platform and having to think about all of these problems up front. Because in the end, effectively, as we go towards cloud-native applications, we're actually thinking about distributed application platforms and how we run across multi-machines. And that's what you have to think about in the world of developers and in the world of operations. So all of this kind of has merged now into this thing that's actually being talked about in the industry as a microservices approach. And how is it that you think about building these applications? And really, at its essence, microservices as a technique, as an approach, really comes down to only a couple of key concepts that you've got to decide whether you need to embrace or not. And what they really are is one is that as you build a service that you want to run and give to your customers, it continuously evolves over time. And as it evolves over time with new features or you're fixing bugs, you want the agility to be able to roll out changes and updates to that service and not have to have downtimes in order to release a service or long development times to roll out a new release. So as you look at all our services now, we roll out lots of changes on a weekly basis. Azure Databases pushes out changes on a weekly basis across all of its features. It builds new features. For example, Azure Databases wanted to build this new feature called row-level encryption, where they wanted to encrypt the data in particular rows inside the table. And they were able to build that feature, rolled out to a few sets of their customers, the oil and gas industry, test it with them. Then they rolled it out more extensively across all the databases, 1.6 million that they're running across all the clusters that they run. And eventually, they then took that feature and actually shipped it in the box product. So there's been this sort of inversion, effectively, of how we develop features and test them and then put them all the way in the box product at the end because we have the agility to kind of test these things in the cloud and have that agility around how we build these things. The other thing as well is around scale. And that's often certain parts of your application or others, I tend to want to scale more. You need to be able to think about how those can scale up and scale down. And so this is the other thing that you run into effectively is that scale is unpredictable, how you're going to run your service. So these tend to be the driving factors, what's called the microservices approach. Now, if you compare and contrast that to traditional apps, sometimes people refer to these as monolithic apps. Typically, you had a set of machines, you built a set of processes, you typically had tiered technologies like a database tier, middle tier technology, and web tier. You compiled, time checked all of those. You still did great componentization and thought about how you factored your system. But in the end, you had a physical set of machines that you tended to look at and deploy a set of fixed processes to a number and scale up the machines and the number of processes across those. In a microservices approach, what changes really is you tend to have this pool of machines. It's a cluster of machines, and the cluster it's more general purpose. All the machines, they can be of different sizes, but you can scale the cluster up, you can scale it down. No one particular machine has one particular characteristic. And instead, you build a set of applications that you can deploy across those set of machines. And each one of those applications is independently versionable, upgradable, and scalable. And so you've ended up decoupling these individual pieces of code at the benefit of being able to scale them up independently and version them independently. Of course, both of these have benefits and both of them have challenges in order to how you approach them all. If we dive in a little bit deeper, when you look at a traditional application, you have all this wonderful, typical, you componentize your application, you have compile time checking. It tends to be easier to think about in some ways because you have this one monolithic set of processes you look at. But as it comes at the expense of effectively very hard to reason about how you scale that application up and how you particularly do upgrades. And so maybe a lot of you maybe experienced today that you end up with long testing cycles, you test a whole product, you ship it all, and it takes several months. And this is exactly where Microsoft used to be with many of its products that it shipped. Its traditional box products fell into this category. Diving in a bit deeper, microservices or application composed of services, you sort of swap that compile time validation really for more runtime validation, where you're actually now having network calls between different services that you run. So your overall application takes on a more like web type feel, where you have calls between individual components. You still got to think up front about those contracts and what they look like, and typically they might be REST calls or TCP calls or whatever the contract is between them all. Tends to be a little bit more upfront thinking about reasoning that, but as a result, you get the benefit of effectively decoupling between individual pieces of code so you can scale them, upgrade them, and version them. And really, I think of this as sort of bringing sort of web principle-like design, where you build a web app and it kind of talks lots of services that may run across various parts of the net, back to the design of the actual application itself. Another kind of characterizing feature, effectively, of a microservices approach is a lot about its state management. Typically, in a traditional approach, you build a database. You have all of sort of primary key, foreign key relationships between a set of tables. So very easy to reason about that single central store in which you kind of access through your middle tier and build a web front end about on top of it all. In a microservices approach, you tend to decouple your state much more, such that your state is more isolated with the actual code that's running. So you end up having more individual state stores, whether they're individual back-end tables that you manage, or whether they're individual databases that you manage, or whether they're actual storage on local machines that you manage in some way. And one of the examples that we used to have like this is Skype for Business. They had an exact app like you see on the left with the traditional approach. It was a classic single database. They put all the calls in there for the conference information, the user information. It used to scale, running 8 machines in the middle tier to like 100,000 users. And then, of course, they were told to take that thing and run it in Office 365, where they had to scale to millions of users and have millions of calls running. So taking that design on the left, they had to effectively migrate their design and think about this in a more microservices approach, where they had to decouple their state around where the scale of the conference call services was different from the other services they had inside all there. So as they took that to the cloud, they realized that they had to have this independence of where they managed all their state stores so they could scale things up differently. Now, Service Fabric, particularly, you'll see dives into the stateless and stateful characteristic, and we treat it very much as first class. We talk about things as being stateless when you run just a little piece of code, but your state might be elsewhere inside some other store. And there's a particular characteristic inside Service Fabric where we also talk about statefulness, where the code and compute the code and the data are co-located on the same set of machines, so you get very fast latency and throughput. And so it's one of the defining characteristics of the platform that helps you build these sort of designs so you can get code and state located together, and often the simplicity of the design. So, sort of summarizing effectively sort of what the key benefits are. You have this effectively to be able to scale independently. I can take an individual service, I can scale it up, I can go from 3 instances to 5 instances to 100 instances, and I can scale it all back down again. I can take and use different technologies to build my services. I'm not tied into saying that middle tier can only be used with a particular type of technology you have to use. Everyone has to do compile time checking and use the same language. Different teams and different people can build services in different ways. It's very common to build web front end with Node.js, but you can use, say, C++ for your back end, as long as you understand what your contracts on the wire look like. You can do independent deployments. I can go from version 1 to version 2. Of course, you've got to think about the messages on the wire supporting different contracts if you change all of those. And a more subtle one, effectively, is that if inside you have a particular sort of shared dependency or conflicting dependency, I should say, often you can sort of split that all out. So that sort of summarizes the sort of key benefits. You've just got to do some of the trade-offs against the traditional design and this, and probably quite likely you'll almost certainly mix and match with them if you have existing code that you take forward to all of this. So in order to kind of think about this and say to yourself, wow, I really need something to be able to design a platform I can build on to help me with all of these microservices architecture designs, you need a platform. And that's exactly what we built inside Microsoft. We built a platform where you can bring along and build applications where you want to bring all sorts of different programming languages and frameworks you want to build on top of that. And you'd love that platform to be able to run in lots of different environments as well. I want to be able to run it in the cloud. I want to be able to run it in premise. I want to have different operating systems to run it on. I want to have my skills transferable and at the same time not be locked in on any one particular vendor or OS to run it on. So this is exactly what Service Fabric achieves. Service Fabric is a platform that we build many of our services inside Azure on, Azure Document DB, Azure Databases, Event Hubs, IoT Hub, Intune, or just to name a few. And it stretches everything from the developer perspective, where you can build applications, focusing with a set of programming models that we provide you to be very productive, all the way through to the operations side, where you do everything from deployments and upgrades of your code to the orchestration of where your code gets placed across a cluster of machines. It builds this elastic cluster that you can scale up and scale down in terms of size and resources. It has failover and reliability of your code, so when things fail, it'll recover your code and place it on other machines. And it has lots of health and telemetry information. You can see the diagnostics of how your app is running, leaving you as a developer to think about how you build the system as a platform to help you operate and run the system. And you can take Service Fabric and you can deploy it in Azure. We have a sort of a managed service that runs there. The benefit of Azure is you can go there, you can create a cluster of machines, and the managed service allows us to come along and upgrade the runtime for Service Fabric on those machines on a periodic basis. But you can also take Service Fabric, just take a set of Windows Server machines, stick them together with a network cable, deploy it across those with a set of PowerShell commands, and create your own on-premise cluster. And because you can do that, you can also take that and run it in other clouds. We actually have a customer who's running in production. They've taken Service Fabric, and they've hosted it running in Amazon. And so they're running their service in Amazon, running it on Service Fabric. And we're fine with that. It's a platform that you can run in all sorts of different places. Of course, there's benefits of running it inside Azure because we provide this ability to upgrade the runtime that's running there. And then finally, I can take Service Fabric and put it on my dev machine. And on my dev machine, the benefits here is that I have the full Service Fabric runtime deployed here. That allows me to do development of my applications and have the full experience as if I've deployed it into any one of these other environments. So I don't have an emulator that pretends to be it. It runs on my laptop. And then we also support the fact that we run on both Windows and Linux. We announced earlier this week that we have our Linux preview, that you can now download Service Fabric, deploy it on Linux Ubuntu SKUs, create a cluster for this in Azure. We have an SDK that allows you to build applications with a Java language and deploy those and build them inside on Linux. And then earlier this week, we also announced the final GA of our on-premise installer, where I can install Service Fabric on-premise. So from a Windows perspective now, we're fully GA that you can build a cluster in Azure using the portal and using the ARM resource model to deploy a cluster, or you can deploy it on-premise, and both those are fully supported products. And here, of course, we tend to focus on .NET languages, at least for now. We'll have other languages that eventually come, and integration into Visual Studio around all of that. So once you have a platform like this, what the other benefits we have from Service Fabric is that we have the other benefits we have from Service Fabric is we want your developers to be fully productive. And so we have built-in programming models for you to be able to build those applications. We have two programming models, one called Reliable Services and Reliable Actors. And I encourage you to go to the talk this afternoon at 4 o'clock. We'll dive a lot more into what those look like. But those are first-class programming languages for you to be able to build applications that run at scale. We also support web applications as a framework, so ASP.NET Core and ON applications can be built first class, deployed as applications onto Service Fabric, and you get first class experience in terms of diagnostics and the ability to manage those runtimes. But because we don't want to be exclusion in any way, we perfectly allow you to also bring any piece of code, we call them guest executables. It could be a Node.js application which you launch, or it can be just a C++ application you build, and you can deploy those and manage those inside the cluster. And then, as I'll demonstrate in a demo later in the talk, we actually also fully support on Windows and on Linux containers that you can deploy inside the cluster. So whether those are Windows containers or Docker containers, you can take your code, put it inside an image, and we have all sorts of capabilities for you to be able to deploy those containers, communicate between them all. So what we find is that actually people have a choice and an approach of how they build their distributed application. And you might come at it and go, well, I want to use a known container image like Nginx that I deploy as my front end, but I'll use the Service Fabric Reliable Services Programming Model to build my back end. Or you might be building it with ASP.NET as a web app and then use a guest executable for some other code that you run at the back end. And you have this choice of how you migrate existing code as well as how you build your application, which makes it incredibly flexible depending on where you've come from and your experiences. And our approach is very much is that we want you to bring your tools and skills to the platform. And over time, we want to incorporate more frameworks, make those frameworks so we can open source some of them so you can bring your own frameworks and plug into all of this. And make sure that we embrace the full developer range of technologies running on any one of these platforms. So the premise of Service Fabric starts at least with this concept of a cluster. You can take a set of machines. Inside Azure, we provision those machines for you, or for your machines, your physical machines inside your data center. Service Fabric gets deployed across them all. When Service Fabric is deployed across them all, they get stitched together to form a cluster that knows about its whole, so you can understand what other machines are inside the cluster. And effectively, at least through Azure, that gets exposed out through a load balancer, and you can then connect in through that load balancer, talk to a Service Fabric management endpoint, and deploy your code across a cluster. In this particular case, I've sort of deployed a web application that gets put on every machine inside the cluster, but you might just have apps that get deployed on particular machines or just a certain number of instances inside there. And then typically, you have a web request that comes in from a client. It goes through the load balancer and hits one of those pieces of code that's running inside there. And Service Fabric has all the smarts to be able to understand where your code is running, how you communicate, or it allows you to be able to communicate between different services you have. If machines die or with processes die, it'll restart those pieces of code inside your cluster. And effectively provides you the sort of system-level infrastructure so you can be able to build your apps on top of all of this. So let's go look at a demo, because it's good to have an idea of what this looks like from a developer experience. I'm just going to switch over to my dev machine here. And once this comes up, which is the wrong switch, is 5. Once this comes up, so here I have Visual Studio. I'm just going to show you sort of the classic sort of hello world, build a service inside Service Fabric. I can go and create a new Service Fabric project. And we have plugins for templates that get created inside Visual Studio. You can see here I create Service Fabric application. If I create a new application here, you see I have a number of different choices that kind of come up. I can build it with the programming models that we provide out of the box that make you very productive for building these apps. But I can also build web apps and pull in just any piece of code to get deployed inside this cluster of machines. And then what you'll see in a release that will be coming towards the end of this year, now that we've GA'd Windows Server 2016, is you'll also have an option inside here to be able to pull in a container image that you might have deployed to a particular repository somewhere, whether it's a local or a public repository. So anyway, I'm going to choose stateless service here. And what this does is it'll generate a Visual Studio project, and it'll have an application inside that project. In Service Fabric, we have this concept of an application. An application here consists of a number of different services. You can have at least one service inside there, but typically 2, 3, as many as you want. And this application as a whole deploys and provisions all of these microservices here in effect. So when you look at how you build one of these things, and this is with our stateless, this is with our reliable services programming model, you'll see that I can just build a class here derived from stateless service. And if those of you are familiar with cloud services, stateless services and cloud services are pretty much identical in all aspects. And I'll explain some of the little bit of differences coming up. But I can build this little stateless service inside here. You effectively get yourself two methods how you talk to your service, which is through a concept that we say a listener. We provide out-of-the-box listeners to be able to talk over web API or through WCF or TCP protocols to be able to talk to this stateless service that's running in the background here. And then effectively you also get this run method here, which allows you to execute and run and put your code there, whether it's your business logic or whatever you're trying to do inside here. In this little template, we just kind of create this little counter here, and we output this counter through to diagnostics. So if I hit build on this, we have great Visual Studio debugging experience here. It'll build this application. Everything is driven through PowerShell. So Visual Studio just runs a set of PowerShell commands, and so you're able to script those yourself and sort of have an integrated experience through your DevOps pipeline. And it'll deploy it onto a local cluster onto my machine. So now on here, I can actually go into my toolbar and actually do Manage Local Cluster. And this brings up our dashboard, we call it our Service Fabric Explorer, that allows me to look at the cluster that's on my local machine here. Now here you'll see that this is the number of applications I have deployed. This is the number of nodes. If I go in, zoom in here, you'll see that all of these nodes here, I have 5 nodes. They're all just running on my local machine. But we give you this description of how your nodes are striped across upgrade domains, which is how you do rolling upgrades for your changes to your app, and fault domains for your failures. In terms of looking at the detail of this, you can actually see this sort of cluster map. This shows it striped across those failure domains. And if you were to look at a cluster like this inside Azure, it's across actual physical racks on different physical machines. Of course, this is my one box it's running on. So this is sort of my node view that I see of my cluster that I can scale up and scale down. We have this sort of system view of where our system services are running. This is all the smarts of the platform, how it does the placement of your code, how it does the discovery of where things are running, how it does the rollout of changes. And you'll see that I actually just deployed this application here. You'll see that I deployed this application type here, which is called type 5. We have sort of named instances. So every instance that's deployed has a particular name. And inside this particular named instance, it creates an instance of this stateless one application here that it was running on node 0 down here. So it picked a particular machine and deployed it onto that machine. And when you build these clusters in Azure, you can actually mix those cluster types together. You can have some machines that are D series in size, some are A series in size. We know the capacities of those machines. And if you use the built-in programmables with Service Fabric, it does a smart and intelligence about where to place all those things. So if I just switch back to, Visual Studio here and go into this diagnostics event here, you'll see that this particular diagnostics event, if I just run the diagnostics events inside here, I have all this counter information that's coming out for the diagnostics from this particular app, and you can get a rich developer diagnostics experience. We can write out events from your app to see what's happening, and these events in turn can also push out through a telemetry pipeline so you can see the whole of what the set of services are running inside the system. So this is sort of a taster, effectively, for your developer experience, what it all looks like. In the talk we have at 4 o'clock this afternoon, we're going to dive a lot deeper inside this and how you can build this is the Windows.NET experience. We're also going to show you the sort of equivalent on Linux and Java. But the message effectively is that we're very focused on how we make developers productive to build these microservices applications. So that was a quick demo. Now, one of the questions you often get is, well, okay, you've got cloud services today, and you've got Service Fabric. How does that whole thing relate? Well, cloud services, great technology. It'll be there for many, many years to come, forever, and as long as there's Azure. And but you can think of Service Fabric. As the next generation, or a bit of an evolution of cloud services, at least, where it did actually solve some larger problems we had there. With cloud services, there was very much this tight relationship between the actual VM and the code you ran yourself. And so when you scaled out an application, you're actually really provisioning new VMs. Well, as I showed you, Service Fabric has this concept of building a cluster. So it's a set of machines. And that cluster of machines allows you to separate out the set of machines from your application. So now I can deploy my applications very quickly because I'm just copying code packages. So you get very fast deployment times and very fast upgrade times of your application. And because you've got that separation, you can also pack in tens, hundreds of applications and get much higher density and utilize your resources a lot more efficiently. And then as I showed you with the developer experience here, the developer experience you get here isn't hidden behind an emulator or isn't hidden behind a thing that pretends to be something that's running in Azure. The bits that we hand out at the SDK every few months are exactly the same bits that we actually roll out and run in all our services like Azure Document DB on a regular basis. So you get the same features and bugs on your laptop as you do inside the same service running inside the cloud. So there's a lot of benefits about thinking about how you build new services running on Service Fabric. And if you have an existing cloud service application today, I may use web roles and worker roles, and you want to think to yourself, I'm interested about how I can take advantage of Service Fabric, and it today communicates with a set of other services, then generally you can substitute almost entirely your web roles and worker roles for building a cluster. We talk about having a sort of a minimum of 5 machine cluster that we run in production, but you can run it on 3 machines. And then you substitute effectively worker roles for stateless services, just like I showed you, and then web roles become ASP.NET or web applications that you deploy inside all of that. Now, if you've only got like 1 cloud service and maybe 2 and they're very underutilizing it all, going to Service Fabric from a cost-benefit basis probably isn't necessarily the best thing that you want to do. But when you start, what we see today is that when people build cloud services, you end up with lots and lots of little cloud services running on A machines, A1s and A2s, and they create hundreds of these things. And when you start to get to 3, 4, 5, and now you're getting up to 10 VMs, and you're getting up to 15 VMs, because you've got 2 VMs per cloud service. So you've got 7. If you've got 7 cloud services, you've got 14 machines effectively running there. You can run that same equivalent on a much higher density Service Fabric cluster and get all the benefits of it all. So there's certainly a cost-benefit approach, and as well as the other approaches in terms of the general management of moving to Service Fabric from cloud services, particularly when you start to build out many cloud services inside your as part of your application. As you look at sort of traditional app, it's like, well, what do I do here? You talked about cloud services, what do I do here? And it's very interesting to think that we've had a number of customers who've had a classic traditional app, and then they've talked about how they want to move to a microservices design. And the message is like, whatever you do, do not try and re-engineer the entire thing at once. If it's a new one, maybe you can start like that. But typically, you want to be able to identify a particular piece or a use case problem within inside your existing app and start to identify, is it an agility thing about upgrading that, or is it a scale thing that you want to deal with that? And if one of those two answers to the question is yes, then maybe you might want to think about moving it to a microservices approach and decoupling things down. And so you almost certainly can end up with this scenario where you have some mixed application for a while, where you deploy some traditional application on a set of VMs or whatever platform you're using on, and then you may use Service Fabric to break out parts of your application into a microservices type approach. One example we had of this, that's written up as one of the case studies I point you to, is a company in the UK called TalkTalk. And they're a bit like Netflix. They kind of provision a set of, they serve up content for media, for movies and videos and TV series. And they built an application where they used effectively a SQL Server database for managing the workflow of all the encoding jobs they had to do. So they took a movie and they encoded it into iOS format, PC, all sorts of different devices. And their demand went up pretty high. So they had new features that they want to build, and the scale hit them in terms of the content of how much they had to encode in content. And so they decided to go up to their application, this workflow that was being bottlenecked through using a database as a workflow mechanism, as a queue. They re-engineered that piece as a set of applications that they built on Service Fabric. And then they were able to scale that up based on their demands. So when they had cyclic cycles, whereby they had lots of content they had to encode or particular demand, they could scale up those applications. And they also had the agility of adding new features, new encoding formats, new types of way of trading encoding jobs and things. And so it was very beneficial for them for that piece of the application. Other pieces like management of users and things like that, they just left alone where it is. So there's a good case study around that called TalkTalk that I'll point you to that you should read. Another one that we've actually also seen as a way of building and migrating some of your applications is if you have IIS applications today, and they're running on ASP.NET 5, and you want to be able to kind of host and distribute those across a set of machines, then we've seen that because IaaS is very bound to a set of machines today, and some of these newer architectures, whether it's Service Fabric or whether it's Docker Swarm or one of the other sort of open source distributed systems platforms, want to deploy apps across these, things like IaaS kind of clash in terms of the same hosting model. So we've seen a great way of doing that is to containerize those and put them in containers and deploy them all. I'll show you an example of what that looks like. And then equally, you can also bring your own existing code and just deploy that as guest executable. So think about what your problem space is and how you're going to break them apart and how you move forward with that. So in that realm, let me show you an example of how Service Fabric, just as a distributed systems platform, can take some of your existing code, and if your first step is to simply go on and take some of my existing code, and without necessarily using all of the programmables that you provide and the benefits of that, I just want to sort of package it up and deploy it in a more agile way. One approach you can do that with is adding it into a set of Windows containers. So let me just switch over to my laptop again. So Service Fabric is I keep going up instead of down. Service Fabric is an orchestrator, and effectively will take a set of either executable images and deploy those as a set of processes, or it can take a set of containerized images that you put up into a repository and pull them all down and put them across a set of machines or your cluster. And with Windows Server 2016 now generally available, you can take those, your code and put it inside containerized images and deploy that across a cluster of machines. So here I have a cluster inside Azure. You'll see now that inside this particular cluster here, if I zoom in, you'll see that it actually consists of 3 back-end machines and 5 front-end machines. They're 2 different types of machines. You see they actually got physical IP addresses now, all set up inside one cluster here of machines. You can actually go and look at the cluster map here, and you see it's striped across physical racks inside Azure Data Center here. And I've deployed inside here an application we've called Simple Container App, and all it does is when you deploy this thing, it pulls down 2 Windows container images from an external repository that will get deployed onto this cluster of machines here. I can do all of this through PowerShell, so I'm going to switch over here to my PowerShell command, my PowerShell administrator, and what I can effectively do here is I can connect to my backend cluster here, and then I can create instance of my application and instance of my service. And when I run this, it effectively creates an instance of my application, deploys it, builds a front-end service that pulls down a containerized image and pulls down a back-end image here. And now effectively I've deployed an application that consists of a front-end service that's just a JavaScript app inside a container, and a back-end service that's just a Node.js app inside a container. Both of those images I just deployed into some repository and pulled them all down. And you see I've got a single instance of my front-end one here. Let me just zoom in a bit here. You can see that's got deployed onto this Node Type 2 machine 4, and the back-end here got deployed onto Node Type 2 machine 2. And if I go and hit this front-end container image here and just call onto this, and if I refresh this, then effectively this will hit that front-end container, which will then communicate with the back-end container and pull back the machine node that it's running on. And let me just try this on another browser here in case it needs refreshing. And there it is. So this shows that my back-end container is running on Node Type 1 VM2. So we're going to look at that. It's on Node Type 1 VM2. So I had a call that came in through the Azure Load Balancer. It hit this front-end JavaScript piece of code running inside this Windows container here, which communicated with this back-end container here running Node.js, which went and got hold of the machine ID it was running on, handed it back here to the page, and rendered that page back to my user. So it's just very simple, but it shows many things. It shows how I can deploy container images. I can map them to ports on the machines. Service Fabric can register those. You can have easy way of communicating between your containers. You can do a whole rolling upgrade mechanism around these. And of course, containers will also provide me resource isolation if I want to do that. And then simply using PowerShell script commands here, I can actually go here and run a PowerShell script command, which will just do an upgrade on my back-end service here. And this -1 simply indicates that I will scale it out across all machines. So if I run this script here and go back here now, you'll see that my backend service will now be scaled out, and I'll get 2 more containers deployed across the other backend machines inside my cluster. So that's me scaling my backend out. I can do the same with the front end. Again, same thing here. Here's my front end service. Here's my my -1 count, which says to Service Fabric deployed everywhere. And then once it runs this update command, it's as simple as deploying that number of instances going from 1 to 5 across the same set of machines in the cluster. So you can quickly scale out your service applications across that all, and you can sort of scale out the actual underlying cluster as well. That gives you sort of your capacity and have the flexibility around how you deal with scale and provisioning of your app around all of this. Good. Right. Wow. I have 10 minutes left. I have so much more to get through. So let me kind of switch over here. But that was all about Windows containers. But really, the point of this is that Service Fabric provides you the flexibility. You can come up to Service Fabric as a distributed systems platform, use the very productive programming models that we provide, or you can bring your own code if you want to wrap that in and deploy it as guest executables, or you can take advantage of Windows containers and deploy all of those. And this flexibility and choice is very powerful of whether you run it inside Azure or on-premise about how you design and build these microservice-based applications. So 2 very common design patterns that we see for how people think about their services as a whole. One's the very traditional where you sort of build a set of front-end web applications. It talks to so another service that does sort of your business logic, and you store all your data in some externalized store like Azure Document DB or Azure or Azure Table Storage. Typically, in order to provide the reliability and consistency between those layers, you send data and messages between queues, whether it's Azure Queue or other queuing technologies like Service Bus, and of course between the layers of your actual calls between your actual services itself. And of course, we also see people build caches that they put there because they want to reduce read latency on the underlying data that they have. Of course, it doesn't address any of your write latency. But this is a very sort of classic design. This is a very cloud services type design. Service Fabric fully supports all of this. How you think about how you build these scaled out applications where you have data and business logic running in your middle tier. And this is a very common approach. Service Fabric takes us a little bit further, though. What it does as well is it says, well, we recognize that there was a pattern now where lots and lots of people wanted the data and the code co-located. And so you can still deploy applications that provide your front-end web application that renders up a web page. But we also introduced this concept of a thing called a stateful service. And a stateful service is very novel and helps you as a developer. And what it does is effectively Service Fabric is a storage technology. And it stores data on the local machines where you're running your code. So now you get code and data co-located on the same set of machines running together. And you can take advantage of that because it gives you very low latency of both the reads and the writes. Typically you got low latency reads because you had a cache, but you had all the complexity of keeping the cache refreshed with the data that was over here. Now your data and code are actually on the same set of machines. You get the benefits of low read latency and fast write latency. And because it's a storage technology, Service Fabric deals with the whole scaling out those individual partitions of your code, and you get to scale out your code and data together. So as you scale out your app, you're actually scaling the data side of it and the code side of it all. So you end up with not only fast read and write latencies or low latencies around those all, but you end up with less moving parts of your application, and you still take advantage of back-end stores. There's no doubt about putting some data into back-end stores because you need to be able to do analytics, cheaper storage, colder storage around this all. But you end up with these designs now where a lot of the data is held in the middle tier where often we refer to this as your hot data, things that you're doing your compute on now, whether it's the last minute, the last day, the last week, or the last year. And then you can offload some of that data to cheaper storage. But this statefulness where you have the local state capable of the compute is a very powerful thing that we built many services on because it allows you to have this design concept of keeping the data and code together. And from a developer perspective, if you go to the talks we have later this afternoon and one tomorrow, you'll see that these are exposed to you through simple data structures. There's a reliable dictionary, reliable queues that allow you how to build these types of apps. We have a whole bunch of customers who've gone into production. These are all the ones who are running in production today, both on-premise and in Azure. And they've been running live systems for a while. And we've captured those case studies in a couple of these links. I talked about TalkTalk one. And we're going to be publishing more and more of these every month or so. We try and publish a new one. And these very much are ones that we've tried to come at writing the case study from a developer perspective. So they talk about the business reasons as well, but they also talk about the design of the application and the choices made inside their role. One classic example that we're also going to try and focus on publishing some end-to-end solutions. So you as a developer can take a solution more than just as individual pieces of code and think about how you use that as a starting point for your applications. And one solution that we sort of started off building out that's very common, both Schneider Electric, you saw on that list, and mesh systems were IoT-type applications. And so we're seeing this very common pattern where people are building an IoT solution where they have some field gateway that sends some data into Azure IoT Event Hub. And then behind that, you hook up Service Fabric to pull out the data from Event Hub and do the business project logic processing inside there, depending on whatever your device is being managed with. So in the case of Schneider Electric, they manage all sorts of different types of power supplies. Mesh systems were managing lighting systems. And they both use Service Fabric for the logic of how they manage those individual devices. And a typical example in here you'll see is that I have an admin application here that you spin up, and that manages an ingestion application which hooks up to IoT Event Hub for how it pulls out the data. And then it's very common inside Service Fabric to spin up an instance of an application on a per customer basis. So in the case of Azure databases, for example, we spin up a database, a Service Fabric application, database application on a per customer basis. So every one of your databases that runs in Azure, if you have one, is an instance of a Service Fabric application. So here, in this particular example, I'm pulling out and creating an instance of a customer application to manage their devices and all the data from it all. So let me go and give you a little demo about this solution. If I switch back onto a remote machine I have here. So this is a solution you can download from GitHub. We're going to continually improve on this. And it consists of a number of different applications inside here. There's this admin application, there's this ingestion one, and there's this one called tenant or customer application. When you deploy this solution into your cluster, you'll end up with 3 applications here deployed. So I'm trying to show you this because this is a bit more of a real-world application. And this admin application allows me to create instances of these other 2. This ingestion application one here talks to Event Hub, and it pulls the data off Event Hub and puts it into this stateful service here, different partition instances where it can cache all that data and keep all the instances of the messages that are coming in. And then from this here, I can create individual instances of a customer application. And interesting, you see here that the customer application has the data service of where the computer's done, and then I have a web service here that provides me a web API to talk to that customer application to get the data from it all. So inside this IoT admin application here, you'll see that there's this web service here front end. When I hit this front end here, it renders up into this nice little portal here. This is just an ASP.NET Core application doing some rendering of AngularJS that renders this front page here, and you can see that it calls on, it knows about, I've created a single tenant app and this ingestion app here. So I can see a view around how I'm doing my admin experience. And then from a usage perspective, I can actually call on to the API for this particular tenant. So I can go up to this particular tenant here and see the list of devices that they have. This is just the API on that web service call that we saw on that tenant or customer application. And I can also go in and using this little client here, send a message into IoT Event Hub, which works its way through IoT Event Hub into that ingestion application off to my particular customer instance. And then I can look at the queue for this particular service. And actually, had I shown it in view before, it would have shown 5, and now I've shown 6 messages. So I can see the messages that have gone through IoT Hub, pulled into that ingestion service and off to my particular customer. So this hopefully is just an example of a more real-world application where I can see a set of services that are stitched together inside application instance that get deployed. and how I can scale out and deploy new application instances on a per customer basis. And so we're going to build more of these solutions that you can use as starting points to helping you get started on whether it's a gaming scenario or a workflow scenario or an IoT scenario, as in this case. So we have a set of talks. I mentioned these earlier. I would fully encourage you to go to these. In fact, you can just go and sit in room A302 for the rest of the conference. It's as easy as that, apart from going from the bathroom in between. And we're going to do later this afternoon a deeper dive into how you build your first applications, look at the developer experience. Tomorrow, we're going to do an even deeper dive into really how you think about the complexities of building your applications using the programming models and that we provide inside Service Fabric. So that's a deeper developer dive talk. And then on Friday, we're going to go into how you do cluster management. We're going to see how you set up a cluster on-premise, how you set it up inside Azure, how you manage that cluster, you do diagnostics, and all the different combinations you can do there. So I fully encourage you to do these talks. The question you might be asking yourself is, how do I explain this to my mother? And if you need to explain this to your mother, we created you a little video. We created this video, which is a little animation. I'm not going to play it for you because it takes 4 minutes, and I've only got 3 seconds left, apparently. So go and watch this little video. And this little video should tell you everything I've told you in 4 minutes or less. And you can play it to your friends and family. And at the end of it all, see, there you go. Tells you everything you need to know. Finally, I'm going to leave you with a slide with a set of resources. Download the SDK. I fully encourage you to go and listen to a course that we've posted on Microsoft Virtual Academy done by Jeffrey Richter, which is several hours of videos of describing how you think about design, building services, and the full gamut of the works. Starting with this, I can't point to it here. Starting with this lab here is a great way to get started. Going to the party cluster, if you go to our samples and if you go to Try Service Fabric, there are free clusters that we host for you. So if you don't want to host a cluster in Azure yourself, you can go and use ones that we host free for you. They're called party clusters, though, because everyone's there partying together. So don't put up anything that's critical to your business. It's really just a place for you to play around with deployments. That IoT sample I showed you is in the GitHub here. And then if you want to ask us questions, we're down at the booth, down in the Expo Hall. If you see Service Fabric, please come and ask us a bunch of questions. But of course, after Ignite, post questions on Stack Overflow, MSDN Forum. And then we have this GitHub account where you can actually report bugs and issues, and we monitor this daily, and we're very active on this, trying to get hold and sort your issues that you may come across. So utilize all these resources. Go to our documentation site, listen to the little video, start the lab course. Actually, this lab course here that we post online is also in the lab downstairs here at Ignite. Hopefully this has given you a little taster. I have some time for some questions because apparently no one else comes in for another 20 minutes just yet. And other than that, thank you very much. So if you want to ask some questions, you can take it at the microphone, or I'll just shout out and repeat them all. Or if there are no questions, you can come to the stage and talk afterwards. We can do it that way.
Mark.
Oh, yes.
Is this on? I don't know. Is this on?
Yes.
Check. Okay. Is the reliable state inherently encrypted?
You're going to have to say that again.
Reliable state, is it inherently encrypted?
Oh, the question is reliable state inherently encrypted? No, it's not. So when you look at the reliable state inside there, what it does is it writes it to a reliable dictionary, which is just like a key value store, and then it writes it out to disk. It'll just write whatever you put inside there. So you will need to do your own encryption inside that, which means you have to do your own your encryption inside there. One thing we're working towards, though, is that the actual VMs themselves, when you write it to the disk, will actually can have BitLocker installed and running on them all. So BitLocker will at least protect the data that's written to the actual disks on the machines. But that's not there today yet, and you have to do your own encryption format when you write it there.
Okay, thank you.
So the question is, can I have a hybrid cloud with a cluster half in Azure and half Azure? Yes, you can have a cluster of Service Fabric anywhere where there's network connectivity. In that case, though, what you'd have to do is create a VPN connection between the two, and you do it all that way. Yes, if you have express route that connects two different systems together and you can keep that thing up, you can create a cluster across them all. We don't do that too much, though, but it is possible, yes. Yes, do we have another question? Okay. Yes.
So, for example, you have like a stateless service, as this service goes, something goes wrong.
Yes.
Fabric, I assume.
We'll restart it all. Yes, I didn't show the restart today because I left all the excitement for the restart for the talk that we're going to do this afternoon. But when you deploy that container across a set of machines and then you fail over the container, I can actually quickly show it to you here. It'll actually just restart the container inside it all. So if I go back and move off this machine here and yes, so what I'll do, look here, is I'll do that. I can actually I can clean up this cluster here. If I run this script here and kill off this application, oh, no one's showing anything. I keep pressing the wrong button. All right, so here. Yeah, so Service Fabric does all the restarting and self-healing of this. So here I don't have an application here deployed. If I deploy this containerized application again across each set of machines, it's going to deploy two containers, a front-end and a back-end container. So there it is. So it's now running here on this front-end. Let's do this back-end container here. This one's running on this particular machine here. So that's running on NT1 VM2. So if I go to NT1 VM2 here, and if I restart this particular machine here and deactivate it all, you'll see this thing switch because it'll shut down that particular machine. And once that machine's shut down, just see if it starts to disable inside here. It'll take a moment to shut that machine down because this is running inside Azure and disabling it inside there. Once that's disabled, this will switch over to, so that's failed over now, and then it'll look at another machine and it'll recover and restart that back-end service on another machine that runs inside the cluster. There it is, so it comes back up. So now it's running on NT1 VM0. So that's my container that's moved. And it took a little bit of time because I had to actually download the container image and put it on that machine, restart the container. And so the containers are slightly slower than processes because processes are faster. Yeah. So that was failover.
Another question. What's the relation between this and Azure Functions?
Oh, what's the relation between this and Azure Functions? Well, Azure Functions is an event-based programming model. And you can think of that as a higher level programming model where you can simply write some code that stitches together other things you have inside your infrastructure. So say you've got some tables that you wrote some data to, and say you've got some data on some other inside a VM, you can use functions to sort of stitch things together. It's an event-based programming model. So we think of that as a very high-level programming model where we talk about it as a stateless, a serverless environment where you're just writing code and deploying it here. In Service Fabric, you sort of kind of get both worlds. You actually have the physical machines that you own and see them all, but you actually have all these high-level programming models as well that you can build against. We would love to go to the direction as well, but I mean, serverless functions will actually run against, so you could build and hooks onto functions that pull things from Service Fabric. Will eventually get there. You can't do it right now. But I think of functions as a very high-level programming model for stitching together the resources that you have.
So what you refer here as like a front-end and back-end nodes?
Yes.
I assume all those nodes or VMs within the cluster, right?
Yes. This is a cluster of VMs that you can own here inside here, and you've deployed a set of containers across all of those, and they can be all sorts of different things. Well, so the question is, what's the difference between a front-end node and a back-end node? Here, it's a case of when the Azure Load Balancer calls come in, they go to this front-end machines first. So these front-end machines here, these front-end machines from here to here are known to the Azure Load Balancer. And so when a request comes in from the Azure Load Balancer, it'll go to one of those 5 machines first, and it'll receive a request. What happens after that is up to you. And in this particular case, I call from that front-end to this one. If you look at this, this is a JavaScript application that runs in that front-end one, and then it asks Service Fabric, where's a back-end service running? And it can actually, just with a pure URL protocol, it just sent a message to it all for you. So all of that messaging is done for you. So that's running on another set of machines, but those aren't visible to the Azure Load Balancer. But the whole cluster is running together. So you can segregate your cluster. Yes? So in this particular case, yes. Yes, you can provide different security rules across the VMs and how the cluster runs and how you connect to it all, and security rules at the cluster level as well as at the application level. Yes, you can put whatever you want inside those back-end machines.
Do they have their own load balancer, or is the software load balancer?
Built into Service Fabric is a way, we have a thing called a reverse proxy, where you can actually do those calls between those different back-end machines. You should come down to our booth and talk to us on our booth for 15 minutes, and we can explain all of that questions to you. Okay, we'll do all of that. In case there's any other particular questions, we'll describe it all. Come to our booth. You're a booth candidate. We'll spend a lot of time with you. We'll do all the pictures and all that sort of stuff. Any other last questions? Oh, okay, good, thank you.